All right, here we have a non-calculator area and volume question. So the first question says find the area of R. So you want top curve minus bottom curve. And your top curve is going to be the cosine curve. And the bottom curve will be the quadratic. So we are integrating, and it shows us, by the way, well, it shows us that our limits of integration are most likely, well, that's definitely 2 because it's labeled. And this is 0 because it's the y-intercept. But again, if you plug in 0, you'll get out a y-intercept of 4 on both of these two curves. So our limits of integration we can figure out are 0 and 2. And then again, top curve, 4 cosine of 1/4 pi x. And I'll put this all in brackets. Minus bottom curve here, 2x squared minus 6x plus 4. And I actually have to integrate this by hand and evaluate it. So cosine integrates to sine. So I'll have 4 sine of pi x over 4. And then by the chain rule, I have to divide by the 1/4, which is like multiplying by 4. So I need another 4 out in front here. Oh, excuse me. I meant to erase that. It's not just 4 it's not 1/4 that I have to divide by. It's actually pi over 4 that I have to divide by. So I'm going to end up, when I divide by pi over 4, I multiply by 4 over pi. And then I integrate, this next one's easier, it just goes to 2/3 x cubed minus 3x squared plus 4x. And this is all on the interval from 0 to 2. So let's go ahead and evaluate. I have 16 over pi, and then sine of 2. This will give me sine of 2 pi over 4, which is sine of pi over 2, which is 1, minus, and then plugging in 2 here, I get 2/3 times 8 minus 27 plus 8. Then if I plug in x equals 0, sine of 0 is 0, and all of these go to 0. So I'm left with just figuring out 16 over pi minus 16 over 3 plus 27 minus 8. And frankly, if you leave it just like this, they will accept it. But for posterity's sake, I'm going to go ahead and figure this out. 16 over pi has to stay as it is. It doesn't combine. 27 minus 8, this goes to 19. 19 minus 5 1/3. I'm feeling like I did something wrong here. I did do something wrong. Have you guys caught it? That 3x squared when x is 2 is actually 12. So I made a mistake. You'll forgive me, I hope. So minus 12 here. So minus 12 plus 8. When I come over here, minus 12 plus 8 is going to give me minus 4. So, in fact, it's minus 4 minus a negative 4, so plus 4. So now I get 16 over pi minus 5 1/3 plus 4 is minus 4/3. Okay, thankfully in part B, I don't have to evaluate the expression. They're saying write but do not evaluate an expression that gives the volume of the solid when rotating around this horizontal line y equals 4. So I need a big R and I need a little r. So my big R is always top curve minus bottom curve. So 4 minus all of 2x squared minus 6x plus 4. And then little r will be top curve minus bottom curve, which is 4 cosine of pi x over 4. So my integral expression is going to be pi on the outside. Limits of integration will be 0 and 2, and then I need big R squared. So 4 minus 2x squared minus 6x plus 4, that whole expression squared, minus little r squared. So 4 minus 4 cosine of pi x over 4 all squared. Close the big bracket there and put in a dx, which is all you need to do for this problem. Just show your setup. So I'm going to have to copy this and start a new page. And we will continue with part C. So now we have the region R as the base of a solid, and each cross-section perpendicular to the x-axis is a square. So I have squares coming out like that. So I need to write but do not evaluate the integral expression. So once again, I'm integrating on 0 to 2, and I've got top curve, which is the cosine curve, minus bottom curve, and I'm squaring the whole thing because it's a square, and that's all I have to do for this one.